Hi there, let's look at 5 practice questions related to some things we've talked about in regards to monitoring the environment. So if you look at the map below, imagine that you've worked for the town of Quiet Corners, which is right here. Right there. You notice that, and you've been managing the drinking water supply. You notice that this year there's been no large emergence of adult mayflies in the water coming into the town, as there has been in previous summers. Well, adult mayflies. What does that mean then? Well, mayfly are a good indication of good water quality, as are stonefly. So when you hear about that, what's that mean? What that means is the mayfly are dying off before they can reach adult stage. And so that's not good. In other words, the water quality has gone down as a consequence. And so what tests could we perform to see what is causing this? We could perform a oxygen test, a dissolved oxygen test in the water supply. We could perform a nitrate test or a phosphate test. And if these two are high, which we would guess they might be, and this was low, then we might be able to pinpoint what the problem is. And if you look, here's the flow of the river into the town. Here's the canola field. That might be an issue, but not for the town because the town is on this side and the river goes past it this way. So canola field might have lots of fertilizer in it. If it has lots of fertilizer, it's going to have lots of phosphates. And so it's going to dump the phosphates in there. But that's past the town. Okay, this is inside the town. There's a sour gas plant, but that is more air quality. And so you might get acid rain, or the sulfur dioxides might get into the water and create low pHs here by the sulfur plant. So this could be a potential source for acid precipitation. And so we might get low pHs of 2 or 3, so that might be a worry. But in regards to this particular issue, our biggest worry and probably the culprit is this feedlot. And so what happens is the manure will seep into the feedlot or into the water supply from the feedlot and probably cause the death of mayflies as well as water quality going down. So if we checked, I bet you what we would find in the water would be leeches, aquatic worms, etc. I'll explain why the following tests are used to determine water quality. So pH, water between the pH of 4 and 9, where 7 is probably the most healthy water. Anything below pH 4, you're not going to find much fish or aquatic organisms, and anything above pH 9. Dissolved oxygen, well, we've talked about that before. Really good water is going to have 8 to 10 parts per million. Anything below 4 parts per million of dissolved oxygen is going to be really, really bad. And then, of course, the middle. So moderate quality 4 to 8, 8 to 10 good, below 4 poor. And phosphorus tests. So if you get high amounts of phosphorus, what's that going to do? So here's our water, and if we have high amounts of PO3 negative or phosphates, that's going to cause algal blooms, and algal blooms are going to cover the lake. Sunlight is not going to be able to get in, and so the plants that live sort of in the shallow areas of the lake or river along the edge, these plants aren't going to be able to photosynthesize. If they can't photosynthesize, no oxygen will be put into the water, and you're just going to get organisms that thrive on anaerobic conditions, which means little to no oxygen. So we have to make sure that water supplies have low phosphorus counts and low nitrogen or nitrate counts, because nitrates can also cause the same thing to happen. Let's practice some parts per million calculations. So if we have 0.003 mils of food coloring in 1,000 mils, what would that be in parts per million? So we set up our ratio 0.003 over 1,000 mils. And right away, if you notice, the units on top and bottom are the same, milliliters and milliliters. So we can set up our ratio and say, okay, how much is that out of a million? 1, 2, 3, 1, 2, 3. So what do I have to times 1,000 by? 10,000. So 1,000 times 10,000 equals a million. And what do I have to times this by? 10,000. 2, 3. So that's 1, 2, 3, 4 decimal places. So the answer would be 3 parts per million. How about if we had 3 milligrams of salt in 100 kilograms? 100 kilograms. Set up our ratio, 3 milligrams per 100 kilograms. And right away, if you notice, if our units are milligrams per kilogram, that's great, because we can then just make it out of 1 kilogram, and we have parts per million right away. So divide by 100 and divide by 100. Divide by 100 means moving the decimal place 2. And so 3 divided by 100 is 0.03 per 1 kilogram. And that's 0.03 parts per million, ppm. Next, we have 6 milligrams dissolved in a liter of something. This one's really easy because this is equal to a part per million. A milligram per liter is a part per million, so the answer is 6 ppm. No extra steps needed. Let's look at this. So look at the table below in location A or B. The waters support the greatest diversity of organisms. Here's location A somewhere, and dissolved oxygen, below 4. pH, slightly acidic, not too bad though, and phosphorus, high. Site B, pH closer to 7, dissolved oxygen in the moderate zone, and a low phosphorus count. So which of these would have a greater diversity of organisms? Cha-ching, this one. And the reason being, it's got higher dissolved oxygen, more moderate pH, close to 7, and less phosphorus. Let's talk about temperature of water. Temperature of water and how that affects it. Oxygen is a gas, and the solubility of gases works like this. As temperature increases, the amount you can dissolve of a gas, which is the solubility, decreases. So it goes down like this, which means colder temperatures allow us to dissolve more gas, including oxygen. So cooler lakes and rivers are going to have more oxygen in it, And as you know, more oxygen usually is good for aquatic organisms that breathe the oxygen in the water. So if we increase this, it's called thermal pollution. If we heat up this lake, that's really unhealthy for the organisms living in it, because what does that do? Oxygen leaves. Okay, the oxygen leaves the water supply. Hopefully that helps some review.